Hello and welcome to the first of the System 63 how to build synth type things recording. Anyway, to start off with here today, we're going to just build a quick little synth in System 63 that'll give you an idea of the connectivity and the things you need to do. The things that you see on screen here, such as the audio in and the mix channel and mix master, these are just so that I can use my microphone to talk to you guys. We'll be using the mix, another mix channel, and connecting that up with the mix master in building this synth. So without any further ado, let's get into it a little bit. So we'll go in. Now if you notice over here we have our mix channel, mix master, and our outputs. Really, to connect a mix channel up to the mix master, really all you have to do is you have to line up the ML, the MR, just right down the road down to the bottom here. What this does is this gives you your main left and rights, your bus 1 left and rights, and your bus 2 left and rights into the main master mixer. Really fairly simple, and then it's a straight audio out from my audio in here to the left and right inputs. So let's get started with actually building a synth. First thing we need to start out with, we go down here into Instrument, into the RA Modular folder, down to Utils, and go to Clock. Now, what the clock is, this is the entire clocking system for the synth. If we look here, you'll see it has a clock output, CLK. That outputs 1/96th beats. Basically what it does is it outputs a steady stream of numbers. It's really all you need to know. It just helps keep things in sync. If you want to dig deeper into that, I am planning on a developers podcast as well for this to kind of give you more in-depth information as to how to develop new modules for System 63. Over here we have P and G. This is pitch and gate. This corresponds to the pitch generator built into the clock. If you see here, we turn on the pitch generator, turn off the pitch generator. This allows you to adjust the pitch which is being generated. Now also on the clock, you see here we have the type. Now this is either OSC or host. Basically what our clock does is it outputs the exact same stream of numbers either way. But the OSC is based on a clock oscillator. In other words, it's all generated from a pulse wave, which is just kicking out that 1/96th tick, and then it's counted and sent out in the exact same format as host. Now what host is if you're going to use this inside of a DAW. So generally, I don't use this inside of a DAW. I just use this on its own, so I usually keep it in oscillator type. So now we'll go back over here. We'll have a look. And we have MW. Let's go into the code a little bit here. Our MW, this is a mod wheel. Basically, when you move your mod wheel on your controller, it's sent out here. AT is aftertouch, V is velocity information. Basically, I put all of those there if you wish to use them. I don't use them a whole lot. RST is reset. This allows the clock to be reset. So when you hit your on and off, it actually can reset the clock and all the counters that you connect up later. CT is for System 63. This is the clock tool signal. Basically, we've come up with this really nice algorithm that allows you to do clock multiplication and clock division in a very, very simplistic way. The CT signal just carries that. If you're more interested in CT, other than how to use it, if you want to figure out how to build modules that use it, then you can go and check out the Developers Podcast. So now let's get something going here. We have a clock. Let's start off with going to an instrument, and we'll drop in an oscillator. Or in this case, we'll drop in the oscillator driver. Now, connectivity to the oscillator driver is really simple to start with. We just need the pitch. So we'll pull that across. Now, oscillator driver comes from the old world of the Moog modular synthesizers. It was a way to have a single point to patch to go against multiple oscillators. And just like the Moog model, I allow up to 3 on that. Today we're just going to use a single oscillator, so let's go ahead and drop in that oscillator. Instrument, RA modular, oscillators, and oscillator. Now from here, we're going to grab the first pitch, and we're going to grab the first width setting. So W1 over to W, and P1 over to P. Now what this does is this allows the pitch to flow through from the pitch generator or from your keyboard. And now here, this allows this width setting to flow through as well. Now here we have frequency, which allows you to adjust the frequency of the oscillator. The range, basically 8 is exactly what the pitch generator or keyboard is putting out. And then these are octaves above and octaves below. So if you're doing a nice bass sound, 16 foot is usually right where it sits. Now, what we need next, like any good synth, we need an envelope. So let's go into Instrument, RA modular envelopes, and we're just going to grab the standard ADSR envelope. For those of you who are really new to synths, ADSR is attack, decay, sustain, and release. This allows you to set that type of an envelope up. So what we're going to do is we're going to grab the gate coming out of the clock. We're going to connect that to the first gate input of the envelope. Now the envelope here, of course, like its name says, we have attack, decay, sustain, and release settings. Now on the envelope, one thing to keep in mind is it's actually a dual envelope. As you can see here, we have 2 gate inputs and 2 envelope outputs. So what we have is an A or a B envelope. This comes in handy. It also takes less space on screen to have multiple envelopes, which is very nice. Now our next setup we're going to use is going to be Instrument, RA modular, and filters. And we're going to use the good old low pass ladder filter. This is a fairly close emulation of the Moog 24 dB ladder. So we're going to take the envelope, connect it to the envelope setting. And we're going to take the mix out on the oscillator and connect that to the audio setting. Now, if you come back over here on the oscillator, the B panel on the oscillator actually has a mixer. So you can mix the type of waveform you want exactly. This is way different than the actual Moog oscillator. Really makes things nice, so you can come up with some very complex sounds without having to have an external mixer all set up inside of it. On the low pass filter, you have your frequency range, which is basically the cutoff. You have regeneration, which is the reso settings, which gives you that nice wow sound. Then you have EG amount, which is your gate amount. We'll turn that all the way up. And a couple of modulation inputs for the cutoff. We'll turn those all the way down. We're not going to use those quite yet. And an R mod setting, which is for the regeneration. We'll turn that down as well. Now, our output from the low-pass filter needs a VCA to go to. VCA is a voltage-controlled amplifier. This is basically the final envelope that it goes through before being mixed in. With System 63, one of the things that I wanted to do was create a mixer which included built-in VCA. So what we do here is we'll just duplicate this mixer. We'll disconnect the audio from it. And now we'll line up the ML, MR, all that, and we will connect those. Now, you notice we also have these S inputs and outputs on the mixer. What we have here is we just connect these up together, and then you take the last one, the top, and connect that to the first bottom one on your mixer. What those are is your solo and your mute signal in the mixer. This allows the solo and the mute to actually work. Just remember that last cable. If you've got a large sound with a lot of different mix points, you'll need that last cable. Now we take our audio out from our filter into the left and the right. Now, if you notice, we also have a C1 up here. This is for the CV or the envelope. So we connect up the CV. Now, you notice down here at the bottom of these mix channels, we have a BCV input. Let's talk about that really quick here. BCV input. This mod amount right here handles the panning of that channel. BCV is short for bipolar control voltage, which all of the control voltage in System 63 is bipolar. Basically, everything runs from -1 to +1. So I'm going to change that just down to CV. BCV was when I was actually considering doing varying levels of control voltage in the system, and I just never used it. So -1 to +1 for your control voltage. For those of you who don't understand control voltage, we'll get into that as soon as I add an LFO to this. So anyway, back to what we've got here. Technically, right now, we have a working synthesizer. Let's see. Is my controller going to work? Yep, there we are. Let's come back over. Okay, now let's do some playing with the envelope here. Let's turn our release down to next to nothing. Turn this up a bit and turn up our decay, and we get... let's also turn the clock into a legato. Okay, so now we have a working synth going, single sound. let's add in a little bit of extra. Let's drop in here, and now let's add in some modulation to the party. Go down to the modulation folder, and we will grab the low frequency oscillator. Now what we're going to do here is we're going to take the second sine output and connect it to the BCV, which will later become just a CV input on the filter. Now what this does is we'll take this and drop that there. Okay, so now let's set our frequency. If you'll notice, we have, this goes to a frequency of 1. This is not the true frequency in hertz. This deals with our clock tool signal. Now, let's turn up the modulation input. That 1 tells you that sine wave is now synced to a 1/1 beat. Everything is actually technically synced. It's just how you choose to put it in. So if we go up to 2, that's a 2/1. Okay, now a 0.5, yada yada. You get the point. Slower input. All right, now on here we can also adjust the output of that sine. On the LFO, the first input is not attenuated. In other words, it is a pure -1 to +1 sine output. The second sine output, or saw output, or triangular pulse output, is the attenuated version. So, like if we go into pulse attenuated, this is going to output a pulse to our modulation amount, and we're going to turn this up to like 8th note pulses. So now we get there would be quarter note pulses. I just found an error here. I'm going to fix it really quick. All right, so now what I did there was the clock really should have 4 voices available rather than just a single. Okay, now let's go into the oscillator. What I'm going to do here is I'm going to shut off this sawtooth and just make this a pure pulse wave. And the reason I'm going to do that is we're going to show off another concept here. We're going to take the output of our envelope into the WM, which is the width modulation. Now, to make this work, since I only have the single oscillator, well, I guess we can just drop in another oscillator. We'll duplicate that oscillator, pitch 2, pitch 2 down to here, and width 2 down to here. So now we need a mixer to mix the 2 mixed signals. So RA modular mixers and mixer. This is good because I really wanted to talk about this mixer. Let's connect the mix outputs to the first two and then two over, and now I'll go explain the mixer. The mixer. These are mix stops. So we have two things plugged in. So we want the second output to be active. So we shut this off to allow these two channels to be mixed together. So what we end up with is okay, let's get rid of the pulse wave so that we have a better way to look at these things. And slow this down to something sane. A 1 over. And attenuate the output. Now, if you'll notice, you'll hear a little bit of phase shifting in there. These oscillators, just like their hardware cousins, are not perfect. A matter of fact, these are so not perfect, they were designed to be not perfect. If you go into the code, you actually see there's randomization of a couple of cents on the pitch of the oscillator itself, which gives you that nice chorusy sound. So let's see. Now next what I was going to do is we have the envelope running into the width modulation 2 running into oscillator 2. So every time I hit a key, this width here is being modulated by the amount of the envelope, which just basically turns the width of the second pulse wave up and down. Okay, let's go back to mono on this. And let's turn that release time up a bit. There we go. All right. Now, quickly, let's have a look at one last thing here, and that's in the mixer master. We have 3 different buses. We have FX bus 1, FX bus 2, and we have an active bus. Now, the difference between these, let's shut these off. The difference between these is an FX bus takes the amounts from bus 1 and bus 2 from your mix channel and treats that as a separate audio input rather than a complete mixed input. So this treats it more like an actual mixer would treat a bus. And now on the active bus, this actually takes your unaffected audio signal, your mix buses, and runs them through. What I use the active bus for most is for dynamics, compression, EQing, that sort of thing. Now let's show you how these work really quick. They're really simple. We will come over here, we will go into effects, and we will add a chorus. Now we'll connect up the bus 1 left and right out, and connect that to the return 1 left and right. Now we've got a chorus effect in there. So let's turn on that bus, and let's send the output from our synth to the chorus bus. Really nice chorus sound. So now you can do the same thing with FS bus 2, only we'll add a delay on there. Nice delay. And you do the same thing. You take bus 2 left and right out and run that back into the return 2 left and right. Now we'll turn that on. We'll send some of our signal over to the delay channel, and we have let's exaggerate this a bit. That's a bit much. Anyway, you get the idea. It's a complete Anyway, all right. I could sit and play with this thing all day. Let's shut that off. Now, up here, this active, that just shuts off both of the effects buses. Now, this works exactly the same way. Drop in an EQ, turn this on, and then you can EQ your final output. The whole mixer system, I know it's not very modular. It is very modular, but it's not very much like what you would see in a hardware module. But then most modular people actually have a huge mixer sitting next to their modular so they can get all those sounds mixed. This just allows you to do that. Also, this allows for some effects propagation, which we'll talk more about later, because System 63, it isn't just a big modular synth, it's also a fully functional effects processor. So it's System 63 isn't this synth. This synth is actually the RA modular. System 63 is the standard by which all of these instruments in Reactor talk together. Now, to show you how cool and how quickly this can change, we'll come in, we'll drag these modules over, and we will drop in the 9663, which is the main sequencer, which is complete right now. We'll connect up the clock. We'll use that clock tool in there. Connect up our pitch output to this. We'll take that first pitch output there, take the gate out of this. Now we're going to grab this BCV and drag this over here to get some really nice, cool sounds. All right. Now we're not really using this for anything, so let's grab the sine and put that into the secondary input. And let's do the attenuated saw into the input on that. So now we have a sequencer connected up. Now, this is where this run runs in, because now you can run the clock. The sequencer is really simple. It's based on the Moog sequential controller. Basically, you have plus or minus 12 in 3 rows of 8. This bottom allows you to turn each step on and off, but only for each row. This allows you to add a glide or portamento to each row. This allows you to set the number of columns per row, and this allows you to set the number of rows. So if you just want an 8-step sequencer, just set it to 1 row. 24-step, 3 rows. Now, on the B panel of the 9663 is velocity. So these are now your velocity settings, or how hard the note is being hit. Works fairly well. Now, if we take these direction settings, you'll notice we have 4 for forward. That plays the sequence in reverse order, left to right, or right to left to right, right to left. Both, which, let's just run it and then you can see it. Ends, plays the end note twice. R side, which moves left or right 1. R side 2, which is basically the same thing, just 2 notes. And random, setting them both to random allows this type of functionality. Now let's go over here to So as you can see, it's pretty easy to set up a sequence where you can do really some cool stuff. Let's do something fun with the attack release. Now let's turn these back on. So as you can see, System 63 as flexible as a regular modular synth. And you'll be able to see even further things the more I get finished here. These modules, by the way, are all pretty much considered ready to go. I'm not crazy about the artwork on the mixer master, and the artwork is not complete for the audio in yet. But then again, nothing else that works on the audio in is completed. So there you have it. That is building a quick synthesizer in System 63. If you have questions, make sure and ask on the Facebook page. Let's see. All right.